If the directions tell you to solve over the set of complex numbers, this means that your answer is imaginary. So you're going to use the opposite of b plus or minus the square root of b squared minus 4ac, and all of this is over 2 times a. This is in standard form, so a is 2, b is 1, and c is 3. X is equal to negative 1 plus or minus the square root of 1 minus 4 times 2 times 3 all over 2 times 2, which is 4. Here we end up with negative 1 plus or minus the square root. 4 times 2 is 8, times 3 is 24. This is 1 minus 24, so this is negative 23 over 4 over 4. Your answer will be negative 1/4 plus or minus I square root of 23 all over 4. And just like up at the top, example 8, this must be separated. In the case of number 11, it is not in standard form because there's no b number. So what we do is we actually factor this. It's a difference of squares. X squared minus 4, x squared plus 4 is equal to 0. Here, these answers are real. Here, these are imaginary. So x squared is equal to 4, x is equal to plus or minus 2. Here, x squared is equal to negative 4. When you take the square root, x is equal to plus or minus 2i. You have 4 answers. If you are asked to identify the polynomial of least degree that has real coefficients, the leading coefficient is 1, and you have zeros of negative 2 and 2i, remember, i's come in pairs. Therefore, if you're given positive 2i, you have to remember that negative 2i is also there. It is implied. Therefore, your factors are x plus 2 from here. This is x minus 2i. This is x plus 2i. You want to FOIL your imaginary first. So FOIL these. X plus 2. This becomes x squared. My outer and my inner become 0, and this is minus 4i squared. So this is x plus 2 times x squared plus 4. This is negative 1. FOIL. X cubed plus 2x squared plus 4x plus 8. Page 10. The fundamental theorem of algebra. Basically, this is saying that when you have a polynomial, there could be some non-constant values that would give you a complex number as a solution. So, by definition, the fundamental theorem of algebra states that every non-constant polynomial has a 0 in the complex number system. Okay? And basically, what you want to do, just like we talked about before, it was in 7.3, we want to use direct substitution and synthetic substitution to determine if g of x is a factor of f of x. Remember, we're looking for either a remainder or a solution of 0. So, if we want to use direct substitution, we're actually going to evaluate f of 1. We set x minus 1 equal to 0, and we solve for x. So we have 1 cubed minus 2 times 1 squared plus 5 times 1 minus 4. This is 1 minus 2 plus 5 minus 4. So f of 1 is equal to 1 minus 2 is negative 1, plus 5 is 4, minus 4 is 0. This is the same thing as the remainder. Therefore, you can say g of x is a factor of f of x. That's by using direct substitution. When you use synthetic substitution, we've done this already, we don't care what these values under here mean. We're only looking for a remainder of 0. So we put in negative 1. We've got 3, negative 6, 0 for x squared because it's missing, 2, and negative 1. Negative 1 times 3 is negative 3. You add, you get negative 9. 9 you add. Based on the fact that my remainder is not 0, we would say that f of negative 1 is equal to 6. Therefore, that's what these 3 dots mean, therefore, x plus 1 is not a factor. In the case of example 2, it says find all zeros of f of x over the set of complex numbers, then write f of x as a product of linear factors. This is a two-part problem. The first thing we need to do is find all the factors, okay? So when we find the zeros or the factors, in this case, this is a difference of squares, so we can factor it. It becomes x squared minus 9 times x squared plus 9. When you solve this, you get x plus 3, x minus 3. Here, when you solve this, remember you get plus or minus 3i, so when you write them as factors, this becomes x plus 3i times x minus 3i. This right here is a product of linear factors. That's your answer. In the case of example B, we cannot factor this. This does not factor. So, in order to find our zeros, we have to use a quadratic formula. So in this case, x is equal to 4 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 2. When we proceed to solve, this becomes 4 plus or minus the square root of 16 minus 52, which ends up giving me negative 36, and this is all over 2. So when we simplify this, it's 4 over 2 plus or minus 6i over 2. So my zeros are 2 plus or minus 3i. When you write them as factors, because this is a positive value, remember you have to write it as the opposite. So the factors would be x minus the quantity of 2 plus 3i and x minus the quantity of 2 minus 3i. These are your factors. Do not distribute. Leave it alone. In the last problem, we are asked to find a polynomial of degree 5 such that 1, negative 2, and 5 are zeros. 1 is a 0 of multiplicity 3, and f of 2 is equal to negative 24. So we have a lot of information here. First of all, it's a 5th degree polynomial, and they give us 3 zeros. Okay, so we talked about this back in 7.3, that right now we don't have enough zeros for a 5th degree polynomial. But if I told you that 1 occurs 3 times, that means when I write this as a factor, it occurs 3 times. It is cubed. Therefore, if it doesn't say anything else about these, we have x plus 2 and x minus 5. We currently have a 5th degree polynomial, 3, 4, 5. Now, the other thing you need to remember is that this tells us that our leading coefficient is not equal to 1. So this is where we said, okay, I want to let a be equal to my leading coefficient. So we're going to evaluate our function when x is 2 and y is negative 24. So remember, f of x was another way of writing y equals. So you have negative 24 is equal to 2 minus 1 cubed times 2 plus 2 times 2 minus 5, and I need to put that a in there to represent the leading coefficient. Here we have negative 24 is equal to 2 minus 1 is 1, cubed is 1, 2 plus 2 is 4, 2 minus 5 is negative 3, and we're trying to solve for the leading coefficient. We end up with negative 24 is equal to negative 12a. So what we found out here is our leading coefficient is 2. So now when I write my polynomial, I have to write it as f of x is equal to 2 times x minus 1 cubed times x plus 2 times x minus 5. Most likely we're going to ask you to leave it like this, but I multiplied it out, so the final answer was 2x to the fifth minus 12x to the fourth plus 4x cubed plus 40x squared minus 54x plus 20. And with this crazy answer, that's why we typically ask you to leave it in factored form.